Okay, so we're trying to come up with coordinates of a lattice rectangle that is 3 times its width is 3 times its length. So one dimension is 3 times its other dimension, whatever. And really, this is probably one of the easiest things we've done yet. It's super simple. So we have to remember, a rectangle has a couple of important properties. One, its opposite sides are parallel, right? Parallel. And 2, its corners are right angles. That's where the word rectangle comes from in German. Recht means right. So rectangle, right angle. So it's a quadrilateral, 4-sided shape with 4 right angles, and it also happens to have opposite sides that are parallel. So there's going to be a million different correct, not a million, there's an infinite number of correct answers for this. In fact, there's no easy way to even, to describe all the correct answers to this. So I hope everybody comes up with something different. So here, just pick a point. That's going to be one corner for our rectangle. Any old point, doesn't matter. And then we're going to pick a second point. So I'll pick, right here. Pick something that's not too far away. Right? So that'll be our second corner for our rectangle. And we notice that we've got a slope of 3 over 1. So that's a slope of 3. So I need my next slope to be, so if slope is 3 over 1, all right, then we need our other slope to be upside down, negative 1/3, right? So that's down 1 over 3. So that would be like over here, right? And then I can just go ahead and connect these, right, like so. It's 7:15 already. All right, so I've got a line there. And then I've got my other, I'm going to draw another, I'm going to kind of, let's see, I'll make these go out a bit. So I want to make sure I draw a nice straight line. So I'm going to plot a whole bunch of points using that slope, down 3 over 1. Go in the opposite direction too. All right, I want to make sure I draw a nice straight line. So let's see here. We'll line everything up real carefully. Okay. All right, there we go. Okay. So now we have a right angle here. Okay. So now all we have to do is travel along one of these sides, right? Some number of units, it doesn't really matter. And then I want to travel along the other one the same, a distance that's 3 times as far as that. Or I could travel along here and stop somewhere, and then travel along this line a distance that's 3 times as long as that. Right? And then once I have 2 points, so I'm just going to pick a couple points like here and here, right? And then all I have to do is I remember that this side and this side down here are going to be parallel, so I just have to draw a parallel line. And remember, parallel lines have the same slope, so this is also going to be down 1 over 3, down 1 over 3. Right? So then I could plot a bunch more points. I connect those, and then I just have to go over here, and I need to have a line that's parallel to this one. So this is up 1 over 3, up 1 over 3. So I can plot a bunch of points there, and where they meet down here is going to be my other point. I could also remember that opposite sides of a parallelogram, and a rectangle is a special kind of parallelogram, opposite sides of a parallelogram are always going to be the same length. So I could just take this point here, and I'll draw that line that has the same slope as up here, and then I'll just find the point on that line that's the same distance down as this up here, which should be fairly easy because I have them marked off. Okay? So, anyways, there's lots and lots of different rectangles you could draw, lots of different methods for kind of figuring out how to do it. And I don't want to go into a lot of detail and provide anything that's super step-by-step, because I want you to kind of think about it and figure it out on your own. So I think I've given you enough information to get started. So let's see what you can come up with. And to do something that's different from what I've done here. Don't come into class with this exact same drawing, right? Draw your own thing.